So in this video, we're going to learn how to divide with roots and how to simplify that way. So you can simplify a root with a fraction in the radicand, and you can rationalize the denominator, which all deals with dividing radicals. So simplest radical form. So far, we've only looked at the first one of how to get perfect squares out of the radicand. We're now going to look at the second and third situation, where we cannot have any radicals in the denominator. So you cannot have this situation. We're going to learn how to get rid of this, or how to manipulate this expression to get an equivalent expression where the radical is no longer in the denominator, or we cannot have any fractions or decimals under the radicand. So you cannot have the square root of 1/2. And we're going to learn how to simplify this or find an equivalent expression where this situation no longer exists. So let's fill out this chart and see if we can see the pattern. So here we have a equals 4 and b equals 49. Well, if I substitute in a for a and b, I have the square root of 4 over the square root of 49. Well, the square root of 4 is 2 over 7. Here, if I have the square root of 4 over square root of 49, well, the square root of 4 and 49 is 2/7. On 2, I have the square root of 36 over the square root of 4, which is 6 over 2, which is 3. Here I have the square root of 36 over 4. Well, 36 divided by 4 is 9. Square root of 9, which is 3. Notice I got the same answer on 2 and the same answer on 1. And then lastly, I have the square root of 25 over the square root of 36, which is 5/6. Square root of 25 is 5, square root of 36 is 6. And if it's similar to the other two, I should get the same thing over here. Square root of 25 over 36. This is 5/6. Well, what that means, since both answers are the same, these two expressions are equivalent, which is just like multiplying. These are both inside, both a and b are in. Well, that allows me to write it as one fraction. So if I have the square root of 2/9, this is the same thing as writing as the square root of 2 over square root of 9. In addition, important thing to point out, and it's a big time saver if you remember to do this, if I had something like this, the square root of 14 over square root of 2, you can treat this as a normal fraction, which means you can simplify. 2 divides 14, this is 7 over 1, so this is the square root of 7 over the square root of 1. Well, square root of 1 is 1. Oh, square root of 7 divided by 1 is the square root of 7. It will actually save you about 3 steps if you can recognize that anytime you're in, the normal operations apply, that you're allowed to divide numbers out. Another thing I want to take a look at, if I have the square root of 3 times the square root of 3, well, the square root of 3 is the square root of 9. And we know the square root of 9 is 3. Square root of 5 times square root of 5 is 25. And square root of 25 is 5. Square root of 8 times square root of 8 is square root of 64, which is 8. Another way you could look at this is the square root of 156, and you can probably predict what's going to happen, is 156 squared. And we learned in the first video, a square and a square root cancel each other out. So this is 156. So square root of a times square root of a is square root of a squared, which they cancel, is a. We'll notice, so what can we conclude, or what conclusion can we make about what's happening here? Well, anytime you take a root times itself, so the square root of x times the square root of x, no matter what's inside, because I have 2 of them, I have a pair, or this means it's x square root of x squared, which cancels them out. it's always going to equal the radicand, which is x. I could have some big number like 1,850 to the square root of 1,850, and it's going to equal 1,850 because I have two of them. I have a square, which they make it simplify out, or do the inverse of. So rationalize the denominator. When I say you want to rationalize the denominator, it's when we're getting the square root out of the denominator. And to use that, we're going to use what we just did, this concept here, that a root times itself gives me just the radicand, gives me the inside. Well, so to rationalize the denominator, again, this is a big math no-no about having a root in the denominator. This isn't simplified. We don't like to have irrational numbers or decimals in the denominator. So we're going to multiply by something to get rid of the radical sign. Well, we just learned that a root times itself gives me just the number on the inside, gives me the radicand. So if I take this times root 2 times root 2 gives me 2. Now I don't want to change this fraction, and the only number if I want something to stay the same, and I still want this to be a, I need to multiply by 1. So I need to multiply by a fraction that it's equivalent to 1. Well, anytime you have the same on top and bottom, this equals 1. So if I have it on top, root 2 over root 2, this really is just a pretty fancy 1. Alright, so I'm multiplying by 1. Root 2 times root 2 gives me the 2 in the bottom. And then I go 1 times root 2. 1 is out. 2 is in. So 1 times root 2 is root 2. I check to see if everything's simplified. Root 2 can't be any more. I have no radical in the denominator. No numbers can simplify top and bottom. So we're done. I can't simplify the 2's because you remember you're out or you're in. The 2 is out. This is in. They cannot be combined at any point. So here I have 1 over the square root of a. So I need to get rid of the root a. So I just need to become a. So I have to multiply by the root a. And then I have to multiply by a top. Again, this is just a really fancy 1. So I go 1 times root a, which is root a. A times root a is a, because I have 2 of them. And I am done. There's no longer a radical in the denominator. Alright, so let's practice this with some other examples. To have 2 over the root 5, I need to remove the root 5 from the denominator. So I need to multiply by 1, and then I need to get just the 5, so I'm going to multiply by root 5 to top and bottom. 2 is out. This root is in. So this is 2 root 5. And then root 5 times root 5, there's a pair of them, so I have 2. And I can check 2 and 5. They do not simplify this fraction. And root 5 does not simplify, so I am done. Again, this is a 2. On B, I have 3 over root 3. So I can multiply by root 3, top and bottom. This again is a fancy 1. 3 is out, this 3 is in, so this is 3 square root of 3. Root 3 times root 3 is root 3 squared, which is just 3. Alright, so now look, I have 2 3's on the outside. I have this fraction. This simplifies. 3 divided by 3 simplifies down to 1. So I have 1 square root of 3. Well, 1 times square root of 3 is just square root of 3, or root 3. C, I need to remove the root 8. So I go root 8 to top and bottom. So 2 times root 8 over 8. Alright, so taking a look, I have 2 and 8 on the outside. That fraction simplifies into 1 and 4. And then I always need to check to see if my root simplifies. So I have root 8, which simplifies down to 4, 2, 2 and 2. So that becomes 2 square root of 2 over the 4 I got from here. And then I gotta check again. Oh, wait, my outside simplifies one more time. So after all that work, this is root 2 over 2. So in H&I, we actually have a fraction under the radical, and you learn from when we did the little chart, let me pull that back somewhere, that when you have this situation, we can split it up like here. That is allowed. The first thing I want you to get used to is that can this fraction simplify? It will save you a lot of time in the long run. So I have 4 over 24. Well, that's actually the same thing. 4 divides in 24 is 1 over 6. So I have square root of 1, 6. Again, I always look for that simplification. They're both in, so I can simplify. Then, from what we learned with that chart, I can write this as square root of 1 over square root of 6. And then, if you look for your perfect squares, square root of 1 is 1 over square root of 6. And now I can multiply the square root of 6 to top and bottom to remove it from the denominator, which again is a big math no-no. 1 times square root of 6 is square root of 6. 6 times 6 is 6. There's no outside number to simplify. 6 is 2 and 3. That doesn't simplify. You are done. There are other ways to do this problem. There's probably 3 or 4 different ways you could have tackled this problem if you didn't simplify right away, and you would still come with the right answer if you did all your simplification correct. So just if you don't catch these little things, it's okay. You'll make it. You're just causing more work for yourself. So in I check to see if my fraction simplifies. 3/20 does not simplify. Alright, so then I can split it. It's to root 3 over root 20. So I can multiply by root 20 over root 20. Well, that is root 60 over 20. And break this down into 6 and 10, 3 and 2, 2 and 5. I have a pair of 2s, so I have 2 square root of 15 over 20. Alright, so checking to simplify 2 and 20. Simplify down to 1/10. So that's 1 root 15, which is just root 15 over 10. Some students are tempted to simplify this, but again, you're either in jail or you're not in jail. 15's in jail, this one's out of jail. They cannot be simplified together whatsoever. And 15 we already know is simplified down to 3 and 5, so we are done. Alright, last 2 examples. Again, check to see, is there any simplification you can do here? Is there any common factors, which there are not? So I can multiply this by 125. 125. So I have 12 times 125. That one I actually need a calculator for. Gives me square root 1500. Alright. And then root 25 times root 25 is 125. Alright, so breaking this down, well, I just multiplied the 2 numbers together. That's 12 and 125. This is 5 and 25. 5 and 5. 12 is 3 and 4. 2 and 2. So putting together, I have a 2 and a 5 that goes out. So that's 10. Square root. And I'm left with a 3 and a 5, 15 over 125. The root's done. I have my 2 outside. Can those 2 be simplified? Yep, they're both divisible by 5. So this is 2. And then this is 25. So this is 2 square root of 15 over 25. Again, I cannot simplify these 2 because one is out in and one is out. Alright, so last example. So I'm going to multiply top and bottom by root 20. Again, I can check to see if these 2 simplify, but they don't. So 20 times 27 would be 540 over 20. Simplify 54 and 10. That's 9 and 6, 2 and 3, 3 and 3, and then 10 is 2 and 5. Alright, so in my denominator I still have 20. What do I have for pairs? I have one set of 3's and one set of 2's, so that's 6. Square it. I have a 3 and a 5 left, it's 15. 6 and 20 simplify, they both are divisible by 2. 3 tenths. So I have 3 square root of 15 over 10. Alright. That is it for this video. Kind of remember, anything times itself is the radicand. That's a very important concept about rationalizing the denominator. And still keep in mind, you're either in or you're out, and then always check to simplify to make sure you're done. Reminder to do your reflection so you get credit for watching this video.